and thank you for joining us today for our first webinar about Solargis Evaluate. Let's give it a couple of more moments until everyone joins and settles in, so let's wait 20 to 30 more seconds. Okay, I think we can start. What do you think, Tomasz?
Yes, go on.
Okay, so welcome everyone who joined us a bit later. So on today's agenda, we have a brief introduction of the company, along with some quick facts for those of you who don't know us already. Then I'll talk more about the current industry challenges and how we solve them with Solargis Evaluate. If you want to see exactly how Evaluate can streamline your feasibility phase of a PV project, be sure to stay with us until the end, where we'll walk you through a live demo of our newly launched software so that you can see firsthand how it works and why it can make a real difference in your workflow. You can submit your questions through the Q&A panel on your right. We'll be monitoring these questions, and at the end, we'll have some time to answer them. A recording of the webinar will be shared with you shortly after the end, so keep an eye on your inbox. Before we start, let me introduce you to your host today. So my name is Dorota. I work as the product marketing manager here at Solargis, and today I am joined by Tomasz, who is one of our product owners.
Hello, everyone.
And together with us, you'll be spending the next 40 minutes. Before we dive into the topic, let me briefly introduce you to Solargis for those of you who aren't familiar with our company yet. We're best known for our high-quality solar and meteorological data. And for a long time, Solargis has been recognized primarily as a data provider, but in recent years, we've grown from being just a data provider to also offering software solutions. And with these combined services, we cover the full PV power plant lifecycle, from pre-feasibility and planning to operation and management. We've been on the market since 2010, and over the years, we've developed our own technology as a result of long-term R&D initiatives that are at the core of all of our products. We have more than 130 employees. We are headquartered in Bratislava, Slovakia, with branches in Canada and Singapore to be able to support our customers from all over the world. Today, we work with more than 1,200 customers in more than 100 countries, and each year, our data, software, and services support more than 9,000 utility-scale solar projects. And while data is the foundation for software, it's important to remember that software can deliver reliable results only if it's built on accurate, validated data. That's why we participated in numerous validation studies, including the most extensive one done by a solar data provider. Unlike other data providers on the market, we are transparent in disclosing the validation site coordinates, as well as the original ground measured data, a link to Solargis satellite model time series data, a report with quality control results, and the validation statistics. So what are the results? As you can see, Solargis data have performed consistently across varying climates and regions, which concludes that they are accurate and reliable for use in PV simulations. We have also participated in the independent worldwide benchmark of modeled solar irradiance data in 2023, conducted by the International Energy Agency. The result of the study has concluded that among 10 distinct solar irradiance models, Solargis data has the lowest average deviation metrics. You can read these two reports as well as other validation studies on our website in the technology section. That's why you can rely on our data, as it is the most accurate on the market. Over the past 15 years, Solargis data have become the industry standard, trusted by the market, and backed by our strong reputation. Beyond data, another way we stand out is through our proprietary technology. We develop all of our technology in-house, including an energy system designer for PV design and PV components catalog, which is an online catalog of verified PV components. Next, we have our very own PV energy yield simulator, which can assess PV power production for up to 25 years ahead. And while we don't leave data as just mere numbers, we also turn it into interactive map services, or you can access our data through API. And ultimately, it's the people of Solargis with their domain knowledge and expertise. We have more than 30 people with PhD degrees in geoinformatics, cartography, meteorology, and electrical engineering. Our digital solutions turn data, technology, and research into real value across the entire PV power plant lifecycle. So when you're in the pre-feasibility stage, you are just securing the land and benchmarking project opportunities and need to perform a preliminary PV energy yield analysis. That's when Prospect will be the right fit for you. And once you've secured the land, you need to work on optimizing the PV design, do a detailed PV energy yield assessment, and secure the project financing. That's when Evaluate will be the right fit for you. Once the site is constructed and operating, you will make use of our real-time data services and energy forecasting capabilities supported by our monitor and forecast solutions. But today we'll be focusing on the feasibility stage and talk more in depth about Solargis Evaluate. So before we go a deep dive into the topic, let's start with a poll. So think about the time when you last did the feasibility study, which I believe that for many of you is your daily bread and butter. And we want to know that during this time, what was the biggest pain point? So there are 4 options to choose from. You can see the poll on your screen. So either it's using multiple tools for feasibility study, low accuracy of solar and meteo data, unreliable PV component specifications, or limited support of energy yield simulation tools for bifacial technology. So let's give it a couple of more seconds until everyone votes. Okay, I think we are very tight on the winner so far. Okay, I think we can end the poll here. And it seems like actually using multiple tools are troubling most of you guys today. So it's definitely one of the topics we'll be talking about later on. So stay with us. So what we learned from our customers is that companies deal with a very complicated workflow when it comes to doing the feasibility study. You might ask yourself why. And typically the workflow looks like this. So the first step is getting reliable solar and meteorological data for your site. When choosing a data provider, you have to look at the accuracy, validation, and uncertainty. And most importantly, make sure that the data is compatible with the simulation tool you will use later on. Current data providers give you just the data, so you need to constantly keep importing them between design and simulation tool. Once you have the data, you want to create a digital twin of the PV power plant. You want to play around with multiple layouts, configurations, and define the electrical settings. And besides this, you also need a good understanding of the surrounding terrain. You might want to import your own high-resolution topography data. You need to choose the PV components and import the PAN and OND files. And you also need to consider the environmental losses for the given location. Now, these and many other inputs need to be collected before moving on to the next step, which is the PV energy yield simulation. The goal is a simulation that's realistic and reliable, so you can generate a bankable report and confidently approach the bank for financing. Now, as you can see, this siloed approach forces you to use multiple tools for every step. It's inefficient, it's time-consuming, and most importantly, it's prone to errors. You have to figure out how to integrate these tools into your workflows, manage different subscriptions, and constantly keep transferring files between these tools because they're not communicating together. That's why each step is represented in a different shape. So let's break this down step by step, look at current industry approaches, and I'll show you how Solargis Evaluate solves them. So let's start off with step 1, data. Most companies today still rely on hourly TMY data, or in worst cases, synthetically generated TMY from LTA data. Working with TMY data smooths out the natural variability, it ignores day-to-day and year-to-year weather fluctuations, and leads to suboptimal system design. And as a result, TMY is not able to reflect the usual variability of weather conditions and doesn't provide a reliable basis for simulations, which is especially important in the context of today's climate change. Regarding your dataset, another major aspect is understanding the uncertainty of the solar irradiance model. When you ask data providers for it, there's a big question mark around it. And you either don't know this number or you are given a generic one. And from a technical design perspective, optimizing the components without the knowledge of data uncertainty is nearly impossible. You must ensure that the selected equipment operates within the manufacturer's recommended conditions, and doing so requires a solid knowledge of the input data reliability. Another very common practice we see in our customers is working with data in spreadsheets. In large teams, this quickly becomes inefficient as files need to be shared across departments, access must be managed, and staying up to date with the latest file version becomes a real challenge. Now, we are not saying that using TMY data is completely wrong. TMY datasets are still useful for early-stage pre-feasibility assessments. However, they're not sufficient for performance modeling and financial analysis. So, by contrast, time series data captures the full spectrum of historical variability. In Evaluate, we use 15-minute time series data spanning up to 30 years of history by default. It accounts for 365 days across the 30-year period, offering a detailed representation of solar conditions, including rare and extreme scenarios. And on top of that, for every data set in Evaluate, you also get the GHI and DNI uncertainty estimates, which are calculated specifically for your location. Working with 30 years of 15-minute time series data in commonly used spreadsheets means opening a file with more than 1 million rows. And I'll tell you one secret, it's actually no longer possible, and we are still not talking about the visualization. However, in Evaluate, we provide a full suite of ready graphs, charts, and tables that help you put the data into context. Part of that package is also the interannual variability, PR calculation, and a year-by-year breakdown of degradation and production forecast for up to 25 years, all based on 15-minute time series data. But don't worry, we'll get to this part later in the demo, where I'll show you what you can find in Evaluate. Here, I just want to show you the difference between TMY and time series data. The figure here shows the maximum air temperatures over the course of 30 years, represented by hourly TMY and hourly time series data. The purple line shows the maximum air temperature values measured in the given location throughout the whole history. And as you can see, the range is somewhere between 40 to 29 degrees, whereas you can see that the green line, the TMY line, shows us just an averaged value of 34 degrees. And I think that we can all agree when modeling site conditions and especially selecting PV components that can withstand such high temperatures, it's more reliable to use time series data instead of TMY, as it provides a more realistic overview of site conditions. Once you have the data for the location where you plan to build the PV power plant, you move on to the next step, which is creating a digital twin. What we often hear from our customers is that many commonly used tools on the market are not intuitive and come with a steep learning curve. On top of that, they tend to have limited functionality, which means that users can't accomplish everything they need in a single solution. They're often available as desktop applications, which limits collaboration, and you are limited to the number of users per license. Another issue we hear our customers dealing with is gathering reliable data specifications about PV components. Today, you can only access the PV component documentation through the manufacturer sales representatives or consultants. And as a standard, these specifications are stored in PAN and OND files, and both formats are just plain text files that anyone can open, modify, and freely share with potentially altered information. Often they come with inconsistencies, multiple versions, and errors. And without the verification by a third party, this creates a lot of uncertainty, and you don't know if the information provided can be trusted. As I mentioned in the beginning that we put a lot of effort into our own R&D, we over at Solargis have taken all of these problems into consideration and developed our very own interface where you can create your PV design in a 3D scene, our very own energy system designer. What is great about this solution is that it's cloud-based, meaning that you can collaborate and share your design with your team and don't have to worry about sharing files the old way. We also don't limit the number of users, so you can invite as many people as you want into your project. You can modify more than 150 parameters and define different types of physical elements that affect the layout. But Tomasz will show you more about the energy system designer capabilities later when we get to the demo, so stay with us. And integrated with Evaluate is our very own PV components catalog, which is an online catalog of verified PV components that you can directly use in your PV design and run the simulation based on their technical specification. If you don't find the component you are looking for, you can always add or import the component according to the data sheet, and the technical parameters will be verified by our algorithms. Now, when we have selected the hardware and the design is ready, we move on to the next step, which is running the PV energy yield simulation. Traditionally, since you did the design in a separate tool, you have to import it into the simulation engine. In modeling solar radiation, most of the industry-used PV simulation tools use the simplified view factor model. And the view factor simulation is fast and easy method for monofacial PV, but it's less accurate when applied to bifacial modules. And this simplified approach does not account for variations in reflections and shading from nearby objects. Also, you can simulate only using hourly TMY data, which does not account for sudden drops or fast changes in solar radiation. And for this reason, you need data with a shorter time resolution than hourly to be able to better predict these events and prepare for high-frequency changes of weather. But I already spoke about this topic in the first step. We believe it's time to move on from these outdated standards and embrace high-resolution time series data as the new standard. That's why we built our own PV simulation engine, which uses 15-minute time series data by default. This way, we are able to capture short-term and long-term variability. And this resolution provides a more reliable representation of weather patterns, allowing you to simulate solar power generation in real-world conditions. Solargis Evaluate is also the first commercial PV simulation solution on the market that uses ray tracing technology based on Perez all-weather sky model. Since bifacial panels now dominate modern solar projects, it's important to adapt the way we calculate their performance. And the 3D ray tracing based simulation allows us to calculate for hilly terrains and bifacial panels, considering site-specific albedo values. To take this even further, we've incorporated automatic simulation of snow and soiling losses using the Solargis model. It accounts for factors such as panel tilt, temperature, wind, and geographic conditions to deliver accurate results. And this global model is natively built into Solargis Evaluate. So now is the time to run the simulation. Once it's done, you can generate our most extensive report, which is the full evaluation of PV energy project based on 15-minute time series data. This report is based on Solargis data, which have been trusted by banks, investors, and other market stakeholders for more than 15 years. Let's take a look at this figure, which compares the number of data points and granularity difference between TMY data and 15-minute time series data. While most industry models still rely on hourly TMY data that provide 8,760 data points, by contrast, the 15-minute time series data spanning more than 30 years of history offer 1 million data points, which is 120 times more useful information than TM1. And I think that we can all agree that with increasing market and weather complexities, it's time to move on from hourly TMY and embrace 15-minute time series data as the new standard. Now, we've covered all of the 4 siloed steps and their challenges. The situation today is that you can complete all of these steps in a single solution. But I have really good news for you today, which is why I believe most of you are here, because we over at Solargis built our own solution that covers everything you need from start to finish. So let me introduce you to Solargis Evaluate, a cloud-based solution providing data, PV design, PV energy yield simulation, and reports in one place. Now, instead of just me telling you about it, we know this is the moment you're all waiting for. So let me give my word over to Tomasz, who will show you what Evaluate looks like in practice. So Tomasz, the screen is yours.
Thank you, Dorota. Have a nice day to you all again. So right now, for this purpose of this demo, I have already selected a location where I designed the PV power plant, but we are planning to do some extension also. So this is our energy system designer and its 3D environment. The first thing that you can notice is that the terrain is already here populated. You can click on the left side to the terrain node, and on the right side, you can see the properties, the available terrains that are already built in right after the activation of your project. You can display the wireframe, so you can see how the elevation points are distributed in your location. And you can also visualize the slopes based on the single threshold. You can adjust the threshold, go a little bit more aggressive with the slope definition, or more conservative. You can also change this view by using keyboard shortcuts. For example, this one is using U, so I can display it on and off just by keyboard shortcut when I really need it. So as you can see, here I have some few arrays that are placed on the objects that we call segments. Right now they are hide to be more realistic, but you can unhide it. And to be able to place an arrays like this, you need to create the segment. There are multiple options how you can create your segments to place arrays on that. The first option is just to draw it by hand. I will show it a little bit later. And the next option is to import it via KML. So here I click to File, Import KML, and now I can browse my file. This is the file that was provided by my colleagues in GIS department. I will open it, and right now you can see the KML structure, that in the root folder of the KML, there are several objects, 4 polygon objects and 1 polyline objects. So now I can see the names of those objects, for example, this parking lot, and I can define how I like to convert it to. So for example, this parking lot will be probably restricted area. This access road will be restricted line. This operational center, this will be a building segment, and this buildable area will be a buildable area. But I will show you how you can convert it even after you import all of these objects. So right now, I will select all of these objects. This access road, I don't want to import it, so I just deselect it, hit continue, and now validation was performed. I'm good to go. So I will hit import button, and you can see that new objects were placed within my design. So here is the parking lot. I can select it. It is in in a constraint folder. This is the access road. It has default exclusion zone. I can extend it a little bit. And this is the building. I can select it. It has a default height. I can increase it or decrease it as I want. And this blue area is my buildable area. So right now I can click on this little button here and convert it to the ground segment. So by this way, you can easily identify the objects imported from the KML. So I will hit ground segment and I can hide this object. So I will end up just with this imported segment, buildable area 14. When I select it, I have here add array button. So I will hit add array and I can place 3 different types of the mounting structure to my segment. So it's fixed tilt, it's 1-axis horizontal NS tracker, and is east-west. So I can click OK, and the array is automatically populated into my segment. As you can see, I can have a different type of structure in one design. So I have a fixed tilt, I have trackers, I can have a different types of PV modules, different types of inverter units, but I rather have the same mounting structure as the rest of the power plant. So I can click on this array, which is already set up, click right click and hit apply properties to, and select the new array that I've already created. And I can even choose the properties that will be copied to this new array, but I'm okay to copy it all and hit apply. And all these settings were transferred to this new array that I just created. I was also asked by our team to move this power station, this power transformer, a little bit closer to our grid connection point, which is here, to lower the cable traces. So I can select the power transformer here and hit the move tool and move it to its new location, for example, here. Zoom a little bit. And when I hit enter, it will be placed, and it has its own exclusion zone, which I can increase to avoid placing tables near this area here. So right now I've removed all the tables around here. And as you can see, the place that was dedicated to this power transformer has been already filled by another tables. So I can go back and select this array, and I see that these gaps are too wide. So I can go to distance between tables and a little bit lower those gaps. Maybe I can fit more tables here. Okay, 0.7 meter distance is just a good fit. And the other option is that I can select the underneath buildable area or segment, and the segment has also these new settings. It's called inner exclusion zone. So this means how apart from the edges of the segment your tables are populated. So right now I can see that this building here, this operational center, in some stages of early sun, I will just hide this segment. Within this, in August especially, it caused some shadows that I want to avoid in these early morning hours. So what I can do, I will just rotate the view, and I can create the exclusion zone or restricted area here. Hit enter, and placing the tables here are automatically avoided. I can hide also this object here, so it is not there for now. So the next thing, I will bring more sun to the scene, so we are not in the dark. And next thing that I can do, I can select this array here, and for example, change the PV module type. Here I have GAA solar. I can change it, and the components from the pvcomponents.com are displayed here. So I can choose from them the catalog of the PV components is a specific website where you can register. You can create your own account. There are a bunch of public items for you to download regarding PV modules and inverters, or you can create your own components that will be kept private just for your company, and then linked your account with the Evaluate, and all those your private component will be available in the Solargis Evaluate in the My Component section. So I can go to the My Component section and choose the PV module that I've already added, this Longi, and I will hit choose. And you can see that it was automatically adjusted because it's slightly larger PV module. So everything was adjusted automatically, and I can continue using this PV module. Okay, so next step or next thing how you can create the array and create the segment is by drawing by hand, actually. So I will again rotate my view. To north, and I will start drawing in this corner. If I press the control, it will lock in the east-west direction. The same for another direction, so I can draw my segment like this. But I remember that there are also some strange terrain objects that I want to avoid. So probably I will draw it something like this, maybe this, and finish it here. Hit enter, and new segment is created. I will hide the terrain highlights, and now I can again add a new array. Select this array that is already configured. We have a keyboard shortcut C that I can copy the properties to another array. I will select array number 5, and it's there. Again, I can decrease the inner exclusion zone here and fill the entire segment by the full tables, because only fractional tables were used here. Okay, right now we have filled the land by the PV tables. Let's move a little bit to the losses section, because here in the losses we have a new tool which is regarding environment soiling losses and snow losses. They both work very similar. So let's hit the edit button. So here you have your default values, 3% every month. Then you can switch to the manual mode where you can define your own values. And the new thing is that you can switch to the Solargis model. So right now you can run the Solargis model with the Solargis data over this specific configuration and calculate the Solargis model of soiling and snow losses. We are considering natural cleaning events. We are considering the configuration of the PV arrays, including orientation, tilt, and you can also define your manual cleaning events. As you can see, this side has no troubles with the soiling losses, but I can still define that I would like to clean in July and in August my PV array. So I will hit the run simulation again, because these manual cleaning events also influence other months' soiling losses. So it needs to be recalculated, but once it is simulated, these are the details that are going straight into your simulation. So you can switch to the monthly time series. You can see even the soiling losses from 1994 to 2024, and you can just hit apply, and it is applied here and automatically goes into the simulation. I just need to check time. I have 1 last minute, so I will quickly show you the CAPEX sheet that we have here. So this is our bill of materials or CAPEX sheet. The logic is simple. The blue cells is editable by users, so you can edit per units. You can edit unit price. For example, this PV module here gets lower the price. You can see the total cost here in a lifetime live update, And here you can see that my new PV module that I've just added has not defined price yet. So all the items that don't have price assigned are yellow. So I will define some price, and it is already calculated. So you have PV modules, inverters, inverter transformers, power transformers, even the table constructions defined. And you can define also the custom items, for example, installation labor here, installation labor of PV modules. And you can link this quantity to quantity in the system, for example, number of PV modules or total installed DC capacity. So you can set installation labor cost based on different values that you have here. You will just set the unit price, hit apply, and you're good to go. And what is cool about this CapEx sheet is that it is live updated in these left corners. For example, if I zoom to this array here and change the spacing, I can play with the spacing. You can see how the capex is lowering because I'm placing less and less tables, less and less constructions, less and less PV modules, and also the installation costs are decreasing. So that's the why that's the reason why the price is getting lower and lower. Once you have your design, we always check the integrity of your design. So you can click the system, and here in the system validation, we have all the validation that you can imagine of. For example, if I'm here, this is my grid connection point, I can select it. Like this, I can select it. You can see it is 48 kilowatts, and this power station, this power transformer, is directly connected to this grid connection. And if I change the voltage, for example, to 46 kilowatts, and then run the system validation here, you can see that transformers directly connected to the grid connection must match its voltage. It is not blocking the simulation. You can run the simulation, but this is just notice that you should adjust your voltage levels to avoid the voltage gap. So I will click adaptive. It will automatically adapt to the grid connection. And now I can check the system validation, and it is done. The system validation is always performed right before the save. So I can zoom out a little bit and hit the save button. It is populated here. I can save it and fix later or not fix it later and perform the simulation. So I will right now go back to the list of my energy system. You can see this one is not simulated yet. So I can click the run simulation button, and then the simulation will be performed, and you will be able to see the results that Dorota will show you. So Dorota, the stage is yours. Turning off.
Thank you so much. Thank you. That was a great demo. And now that we know how to create the PV design and run the energy yield simulation, I'll take over to show you the analysis section and reports that are included in Evaluate. So once the simulation is done, which you can see here, you don't have to leave Evaluate to visualize the data in third-party tools. And with our extensive analysis section, you have access to various charts, tables, that provide a great overview of the site's conditions. So let's take a look. So we go here into the left side. As you can see, we have the analysis section, and we divided it into 4 parts. So we have the solar resource data, climate data, environmental parameters, and the PV statistics. So for example, let's take a look at GHI. And for each parameter, you can select the data set that you want to visualize. So in this case, since we already have the PV system and we ran the simulation, we can choose this time series data set based on our PV configuration. If we don't have that yet, it's still okay, because you can just take a look at the analysis of time series or TMY data for the given location. Now, each parameter can be explored into more detail from yearly to sub-hourly resolution here in the upper tab. And each graph can even be exported if you want to share it with someone or include it in a presentation. Most of our graphs are interactive, so when you hover your mouse over it, you can see the numbers and the ranges for the given graph. Once you run the PV simulation, you unlock this PV statistics section, and you have information about PV out, PV system losses, and the long-term degradation. And the uncertainty that I mentioned is available here once calculated. So here in the downloads, we can go over to the reports where you can generate different types of reports. I won't go more into detail about them because all of the samples are available on our website, so you can download them and go through them. But I'll show you the most extensive one, which is the full evaluation of PV energy project. So the report has 30 pages summarizing all information about the location and the PV configuration, as well as information about the Solargis data. Everything that you can find in Evaluate is summarized here, including the most important tables, charts, and graphs, and everything that you need to do the analysis. So let's go over to chapter 7, which I believe is important to many of you, which is the PV chapter. And this section includes the summary of the PV system losses, and then we have the conversion stages of energy losses, and then the monthly losses and PV power generation broken down from yearly up to 15-minute data granularity. So that's it for the demo. And as you could see, Solargis Evaluate addresses all phases of solar project evaluation up to due diligence, and it's aimed for developers, EPCs, technology suppliers, investors, and technical advisors. And as a web-based platform, all of your projects are securely saved and backed up in the cloud. But most importantly, it integrates the 4 key phases of the evaluation process into one solution. So we hope this gave you a clear overview of how Evaluate can simplify your workflow. And we still have, okay, we don't have much more time, but let's try to answer 2 questions from the Q&A. So I see we have some really good questions coming in already. And yes, so okay. We have a question.
Quick, so maybe we can answer 3 of them. So one is, yes. I have noticed shadows in the 3D. Are these shadows accurate for the site location over the different seasons of the year? Zachary, yes, it is. We have accurate some geometry, so you can count on the shadows that you are seeing in the application. Then I would like to pick, because we have multiple questions. How long does it take for one simulation usually? Example, 20 megawatt AC PV park. Julian is asking.
So yes, I can answer that question. So for a 20 megawatt peak power plant, the simulation time is under 15 minutes. And this runtime is driven by the use of 15-minute time series data with more than 30 years of history. And it's modeled at the individual cell level. But what is more important is that you can run multiple simulations at the same time, and we are not blocking your hardware resources because everything is processed in a cloud. And yeah, let's try one more question.
Can I pick one?
Yes.
Julian, again, you mentioned ray tracing. Do you calculate the energy production for each individual PV module for each 15-minute step? Yes, that's true. And we are not calculating just for every PV module, but we are calculating for every cell. So we are running ray tracing for every PV module cell. The multiple parameters are as an output, like a temperature, voltage, the power, and so on. And then we are combining all these results into the file number. And we need to say that the 15-minute step is just a default resolution. We are allowing also to run the simulation over 1 minute resolution. So you can do that too.
Okay. Okay, so that's it for today. As we are already out of time, the questions that we did not have time to answer, we will be following up with you in an email. So expect an email from us. But thank you all for joining today and staying with us until the end. And if you want to learn more and book a demo, you can reach out to us at contact@solargis.com, or you can go to our website to fill out one of the contact forms and we'll get back to you. And the recording of the webinar will be shared with you shortly after the end. Thank you again and have a nice rest of the day. Goodbye.
Thank you. Have a nice day. Bye.